I hope we didn't write this one down.
Oh, I had like.
Okay. Do y'all need to see that again? Are you all good? I can put it back up there. Does anybody need to see it? No? No? Okay. All right. Yeah. Inverse function. Okay, so real quick, I am the worst and I didn't grade your test yet, but I'm almost done and they'll be in by tonight. So a couple of things just real quick before we get into the next unit, which starts with inverses. On Thursday and Friday, I am going to a wedding and I won't be here. So the reason that sort of might matter to you is that there's a UIL eligibility deadline on Friday. So your test grade will go in by tonight, pinky swear. But then tomorrow is the last day that you would have to turn in work with me before I leave. Or it's like an out of state wedding. I'm not going to be like checking my email. I'm in the wedding, blah, blah, blah. So if you have questions about your grade, let's get them asked today or maybe tomorrow. If you have work to turn in, do it. Email me. I'll be happy to put it in. But Thursday, Friday, I won't be here. The last thing I'll say is that this class technically for UIL doesn't count towards eligibility. That does not mean that your coach won't make it count for their sport. So they could say, I don't care that pre-cal is not a UIL course. I still am not gonna let you play. That's their decision. Okay, but technically you're at an advanced math level where this doesn't affect eligibility. Okay. So on Thursday, you'll have a sub. I will make the notes much shorter than last time because I think that they were kind of too long. But hopefully that day will go just fine. Hey. Thank you. When convenient. Aiden is for you. I'll send you back.
Okay.
Okay, do y'all remember doing inverses in Algebra 2? Long ago? Maybe, probably not. Okay, an inverse is going to be f to the -1. So if f is the original, f inverse would be with the little -1. Now, there are two ways to do inverses. The first way is graphing, which is a little bit easier. For a point xy, your solution to the inverse is going to be yx. What is the difference between those 2 points? What do we do with the x and the y? Just switch them, okay? So if you had 5, 2 as a point for your original, 2, 5 would be your inverse. If it's 0, 10, it would turn into 10, 0, okay? And then y equals x should form a line of symmetry between the function and its inverse. Okay, so let me show you what I mean by that. Let's look at number 1. What shape is equation number 1 gonna make? Right here. Parabola, v, line, square root. Line is correct. So this is your m. This is your b. So I'm gonna begin at +2. And then I'm gonna go -1/4 would be down 1, run 4. Down 1, run 4. So down 1/4. Down 1/4. Now for your practice questions on this, you have to get 5 points. So if I go down 1/4 again, I'm gonna be off the grid. So I'm gonna go up and backwards 4 to get my other 2 points. So up 1, 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then connect your dots. And then we're gonna take those 5 dots on our line and we're gonna put them in our table for f of x. Okay. So I'm gonna start with this point. Can you count the coordinates for that? Should be -8, And then up what? 4, so it'd be negative 8, 4. Okay, then my next one would be negative 4, 3. We're just recording these points. Okay, what's this middle point here, the y-intercept? 0, 2. Okay, then I have a point over here, this would be 4, 1. And then this last point here was just 8 to the side. Because remember, we went over 4 twice. That would be 8 here. Okay, so now for the inverse, all of those points are just gonna be backwards. So I'm gonna switch to a different color. If you have a different color, do it. If not, it's fine. Okay, but this is my original f of x. And then I'm gonna graph the new one in a different color. So if it was negative 8, 4, what is that backwards? Just flip the order. 4, negative 8. And so for negative 8, I'd go 1, 2, 3, 4, down 8. Okay, my next point was negative 4, 3. Flip that around, now it's 3, negative 4. So I'll go 1, 2, 3, 1, 2, 3, 4. Okay, this was 0, 2, what's that backwards? 0, 2 would turn into 2, 0. Okay, 2 more points left. 4, 1 is now 1, 4. And then last point was originally 8, 0, so now it would be 0, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. And the red line that I just graphed would be considered the inverse. Okay? So let's go back and look at what we wrote in our blanks once you're done with that. Okay, we said for every xy, it's going to become a yx. We did that. And then this statement says the line y equals x should form a line of symmetry. So I want you to kind of turn your paper sideways. This is y equals x right here, this diagonal. Do you see how it perfectly cuts your graph in half to where each side has kind of like a matching shape? Okay, that's what a line of symmetry is. Hopefully we know that already. Okay, but you're gonna have to kind of turn your paper sideways to see it, because it's not a line of symmetry this way, it's a line of symmetry down that diagonal. Okay.
Do a eagle, pardon the interruption. And here.
This side.
So please be in the right if you live in the Dallas County area to register to vote. We are set up in the hall and we'll be there all lunches today. And if you register to vote, that will include you as well. You do receive a thank you. So again, if you're set up here in 10 months, please stop on the right, so sorry, in the hall, we're all lunches to register to vote. Thank you guys. Happy Tuesday.
Okay, so your line of symmetry is always at that diagonal. If it doesn't create a line of symmetry, you messed up one of your points, you're disciplined. Okay, go down to number 2. What shape is number 2 graph gonna be? Okay, just looking at the equation there. Gonna be a V. How is it gonna be shifted? -3 means right 3, -5 means down 5. So 1, 2, 3, 1, 2, 3, 4, 5. And then remember that the number in the front tells you the rise over run for your V. Okay, so if it's a 2, that's 2 over 1. So I'm going to start here and I'm going to count up 2 over 1, up 2 over 1. Now notice I only need 5 points. So I'm just going to do 2 on each side. So then I'm also going to go this way, up 2 over 1, up 2 over 1. You could keep going, but you only need 5 for your practice today. So I'm just going to kind of connect the dots from there. Okay, that's f of x, the original. Okay, and then, we're gonna write those 5 points down, then we're gonna reverse them and graph the inverse. So let's start with this top left point right here. Can you give me the coordinates for that? Okay, 1, -1. Next point here would be 2, -1, 2, 3. What about that vertex point? What's that? 3, -5. Next one would be 4, -3. Because I see it's even with that other -3 point. And then this one would be 5, -1. Okay. Go ahead and label though, that V that you did, that's the original F. And now when we switch, for me, colors, okay, I'm now graphing the inverse, which is where the points are reversed. So 1, -1 is gonna turn into what? Yes, -1, 1 would be here. Next point was 2, -3, so now it's -3, 2. 1, 2, 3, up 2. Next point was 3, -5, so now it's -5, 3. 2, 3, 4, 5, 1, 2, 3. Okay, 2 more left. 4, -3 is now -3, 4. 1, 2, 3, 1, 2, 3, 4. And then -1, 5 will be the 5th point. Okay, once you get your 5 dots, just kind of connect your lines. You should notice that your V that used to open up, how does it open now? It just kind of opens to the side. And it doesn't have to be perfect, just do your best. What should I see when I look down my diagonal line? Starts with the S. Symmetry, that both sides should match. So once you've done it, I'm going to turn my paper sideways and just make sure that both sides match. Okay, I see that I have this weird little triangle on both sides. And then I have a random line sticking out on both sides. So that does look symmetric. That means that we did it correctly as far as graphing goes. Questions on that? Okay, now let's go back and review a concept from Algebra 1. Do you remember that what makes a relation a function is if the x's don't repeat? Do you remember hearing that back in Algebra 1? Y'all took it in like what, 8th grade? Okay, so your x values, if it's a function, cannot repeat. And if it's a graph, you do what's called the vertical line test or the pencil test. Does that sound familiar? Yes. Okay, what did y'all call it? Vertical line test or pencil test? Vertical line test. Okay. So there are 2 ways to check. If you're looking at a table, you want all your x's to be different. If you're looking at a graph, you want all of your line to pass the vertical line test. So let's look back at number 1. Now remember, we're only doing one function at a time. So for this straight line that I'm kind of putting my fingers over in green, would it pass the pencil test by itself? Pretend the red line's not there. Would it pass? Okay, yes. What about this red line? Would it pass? And then remember, here's the rule. When you draw a line through it, it can only hit once. That's what the pencil test is, or the vertical line test. So if I drew a line through my green line over and over again, would any of those lines hit it twice? No. Then this one is a function. Okay, because it passes the vertical line test. I'm going to call it the VLT just because that's shorter. Okay, and then the same thing for the red one. That if I come in with vertical lines and I slash through my graph up and down over and over again, none of those lines will ever cross twice. So the inverse also passes. Let's see if that's the same for number 2. Look at your green V. Okay, yours probably isn't green, but this one. Okay, if I look at the green V, would it pass the vertical line test? Okay, let's see. As I draw my lines, do any of them hit the green V twice? No. No, then it passes. So is it a function? Yes. It passes the VLT, vertical line test. But when I go to my red V, and I draw in a vertical line, is the red V gonna pass? No, because when I draw that line in, how many times is it gonna cut through the red V? Twice, that means it fails. It's only allowed to touch once. Okay, so is it a function? You would say no, because it fails the vertical line test. Okay, the other thing that I said is that if your X's, they're not allowed to repeat. So do you see in this chart that all my X's were different for the original? 1, 2, 3, 4, 5, none of them repeated. But on this one, were they all different? No, you have several repeats, right? The -1s repeat, -3s repeat. And if we had kept going down the V, there would have been even more repeats. Okay, so it fails not only because of the graph, but also the chart itself will fail. Okay, so you should be able to check either way. Okay, turn the page. We're gonna do one more graphing and then we're gonna move on to algebraic. So last one we're gonna do for this is number 3. Okay, you'll notice that you have a square root x minus 4 plus 2. Which way are we shifting? For the 4? Okay, to the right 4 and then up 2. So that'd be 1, 2, 3, 4, up 2. And then remember that your square root function, okay, it does this where it kind of like just arches to the side. It almost kind of looks like the shape of the square root symbol. So I'm going to start here and I'm going to go up over 1, up over 3. Up over 1, up over 3. Now, for your practice, you're not going to have square roots because how many pretty points do those give you? Only 3. And on your homework, how many do you have to do? 5. So these won't show up on there, but you do it the same way. So we're just going to do it. Okay, so what's my first point right here? Give me the ordered pair for that. 4, 2. Okay, then my next point was over and up from that, so it'd be 5, 3. And then I need one more pretty point, so I'm going to use this one right here. That would be 8, 1, 2, 3, 4. Okay, then how do I get from F to the inverse? I just reverse that order. So if my original point was 4, 2, now it's going to be 2, 4. So 2, 4 would be here. 1, 2, 3, 4. 5, 3 would turn into 3, 5. Which would be here. And then 8, 4 would turn into 4, 8. So 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. And then if you connect those dots, you should still see that you have that symmetry down that diagonal. And if you kind of twist your papers on the diagonal, okay, both sides are going to match each other. Okay. All right, let's do the function thing. Green by itself, pretend red's not here. If I draw in vertical lines, are they ever going to hit twice? Then does it pass? Yes, so it is a function for green. What about for red? Okay, pretend green's not here. Drawing your lines. Are they ever going to hit twice? No. No, then it passes. So those are both functions. So sometimes your original and your inverse are both functions. Sometimes the first one is, the second one's not. It's also possible that that could be reversed. Your original is not a function, but your new one. Okay, so 2 ways to check that. X's can't repeat in the chart or vertical line test on the graph. Are we all good with that? Okay, now let's figure out how to do them algebraically. Okay, we're going to skip number 4 just so you have more time to work on your practice. Okay, to find an algebraic inverse, there are 3 steps that you're going to follow. The first is you're going to switch the variables x and y. Now, if your equation has f of x equals, that's the same as y. Okay, so like up here at the top for those examples that we just did, do you see how it says f of x? That's the same as y equals. Okay, so if you want to change that on the one above that where it says f of x equals, this is really just y equals. Okay, so if you have an f of x in your mind, you should know that's really the same as y. So the first step is gonna be to swap those letters out. Then step number 2 is optional. You're gonna switch the sides so that your y is back on the left. And then you're gonna get that new y by itself. So let's look at number 4. Let's follow those steps. Step number 1, I'm gonna replace the x and y's position with each other. So instead of y equals, now it's what? X equals. And then instead of a fourth x plus 7, now it's a fourth y plus 7. Step number 2 is optional. I don't like solving with y on the right side, so I'm just gonna do a switch. So I'm gonna let this side come first, 1/4 y plus 7, and then I'm gonna equals x on the other side. Okay, that's completely optional. You can solve with y on whatever side you want. This is just a preference for me. From here, how do I get rid of plus 7? Minus 7 off both sides, very good. So then I have 1/4 y equals, x now has a minus 7 with it. And then if it's a 1/4 y, that means divide by 4. How do we undo divide by 4? Multiply by 4. So when you multiply by 4, you have to multiply the entire side by 4, which means I'm gonna group and times by 4 in the front. You're not just timesing the x with 4, it has to be the x and the 7. Okay, from here, you have y equals 4 parentheses x minus 7. Now, would there be one more thing that we could do with that 4 to maybe make that a little easier? Okay, distributed it. This step is optional. For your practice today, it'll take it either way. But I'm gonna finish it just because I think it looks better. So that'd be 4 times x is 4x. 4 times 7 would be 28. So that would be the inverse equation for what you started with. Make sense? All right. So now let's look at number 5. Okay, first thing I'm gonna do is switch those letters. So instead of y equals 6x minus 10, x equals 6y minus 10. Step 1, switch the letters. Step 2, switch the sides. So my 6y minus 10 is gonna come first. My equals x is gonna come second. How do I get rid of the minus 10? Plus 10. So I have 6y equal x plus 10. The next step, I have to get rid of a 6. That's like a multiply 6. How do you get rid of multiply by 6? You need to divide by 6. There are 2 ways for you to do that. You can do a big fraction over 6, or you can 1/6 both sides. But if I want to 1/6 this entire side, what do I need to put it in? Okay, very good. Now, is that the same as doing x plus 10 all over 6? Yes, and you could write it either way, your practice will kind of correct. Okay, so I have y equals. Now, would this be easy to distribute into a 10? Does 10 divide by 6 easily? No, then I'm just gonna leave it. Okay, because remember, your practice will take it either way because they're equivalent. Okay, but I'm also gonna write it like this because I saw some kids in the other class did like it better as a big fraction. Okay. So really, both of those are fine. It's up to you what you think looks better. Questions on that? All right, now, obviously, both of those were straight lines. You're gonna see other types of functions on your practice. So turn the page, we'll probably do 4 more examples. Make sure you remember how to do it, and then we'll start on your results map. So turn the page, number 5. What type of function is number 5? What's the little exponent? A cube, right? How do we get rid of a cube? Eventually, cube root. Okay, so up here at the top, just fill in for nonlinear functions where it's not a straight line. inverse operations cancel out. So if you have a root and a power of the same value, those will cancel out. So here's what I mean by that. If it's a cube, you're gonna use a cubic root. What if it's a squared? You would use the square root. Okay, now eventually we'll get into weird powers where what if it's 7th power? Then you would use a 7th root. So as long as it's the same type of root as you have a power, then they're gonna cancel out regardless. Okay, so let's do number 5. Step number 1, we're replacing the x and y's positions with each other. So instead of y equals, it's x equals 1/4. Now it's a y minus 2 cubed minus 10. Now, I don't want to have to rewrite that whole thing to switch the sides. So what I'm usually going to do to just be a little lazy is just take the x equals and make it an equals x. Okay, it'll basically reverse your sides for you, but where you don't have to take up the space to rewrite the whole thing. Okay, what are we getting rid of first? Think about the other examples that we did. 10, it's a minus 10, so we're gonna plus 10, add 10, very good. So add 10 here, add 10 here. So I have 1/4 y minus 2 cubed x plus 10. Next step, what are we getting rid of? 1/4 means divide by 4. How do I get rid of divide by 4? Multiply by 4. So I'm going to multiply by 4 here and here. Cross these out. Y minus 2 equals. What is wrong that's going to end up messing up the whole rest of my problem? Parentheses. And then remember, at this point, you can pick, do you want to distribute the 4 or do you want to leave it? If it's a whole number, I'm going to distribute it. So 4 times x would be a 4x. And now that 10 is a what? 4 times 10 makes it a 4. Okay, from here, how do we get rid of a cube power? Cube root. And remember, a cubic root is like a square root, but you just put like a little 3 in the elbow. Okay, and then a square root over here, little 3 in the elbow. Okay, when you cubic root on a cube, those cross out. The only thing that you're going to keep is the y minus 2. And then how am I going to get rid of the y minus 2? Plus 2, very good. And then quick question, can I add the 2 to the 40 that's already over here? Okay, correct answer is no, because since the 40 is on the inside, you do have to add the 2 kind of separately. So it would be y equals cubic root 4x plus 40 plus 12. Oh, I'm blind. Yes, that's it. Good with that? We do one more. Okay, let's try number 7. So you have 1/2. This time we're starting off with a cubic root. It was an x minus 5, so I'm changing it to a y minus 5. Plus 14 equals x. Notice that I'm swapping out the y equals for an equals x on the other side. What are we doing first? Okay, we got to get rid of the plus 14 with a minus 14. So I have 1/2 cubic root y minus 5 x minus 14. Next step, I have a 1/2. That means divide by 2. How do I cross it out? Multiply by 2. And then when I multiply by 2, remember you got a parentheses what was already there. Because not just the x times by 2, but also the 14. From there, I have the cubic root. Y minus 5 equals, I'm going to distribute. So 2 times x is now a 2x. 2 times 14 becomes
20.
From there, I got rid of a cube with a cubic root. Then how am I gonna get rid of a cubic root? Use a cube. So you're gonna cube and cube. Make sure you group and cube everything on that side together in parentheses. Cube and cube root are gonna do what? Which means really you're just left with a y minus 5. How do I get rid of the minus 5? Plus it across to the other side. So then it'd be y equals 2x minus 28 to the third power plus 5. Okay. Questions on that? All right, we need to do one with a whole number in front, so let's do number 8 right next to it. Okay, go ahead and switch your letters. After you switch your letters, you're gonna switch your sides. So 6x plus 4 is now gonna be 6y plus 4. And then equals x. What are we doing first? So we'll take our minus 25 and we'll add it, right? So you'll have 6y plus 4 cubed, x plus 25. Okay, from here, it's not a divide by 6, it's starting off with a multiply by 6. So how do I get rid of a multiply by 6? Divide. You have two choices. You can do a big fraction over 6, or you can do a 1/6. Okay, it's up to you. They're both right. Okay, but I like the 1/6 in front better. Now, if I could divide both of those numbers by 6, I would distribute it. But can 25 divide by 6? Then I'm just gonna leave it. So I'm gonna leave that parentheses there. So now I have y plus 4 to the third power equals 1/6 x plus 25. From here, how do I get rid of a cubic power? Cubic root. And when I cubic root, I just have to make sure that everything over here makes it into the house. It's not called a house, it's called radical. Okay, everything needs to make it into the radical, so it should look like that. Okay. And then when I cancel out the cube and the cubic root, those parentheses that I had under there also can go away as well. So we won't need those anymore. So now it's just a y plus 4. And then how do I get rid of the plus 4? Can I minus it from the 25? No. So it would be the cubic root 1/6 x plus 25 minus 4. Questions on that? Okay. Last one we're gonna do, we want to do one with a different power. Let's do number 9. So go ahead and switch your letters for me. So it was originally a 7th root of x minus 5. So we're gonna swap that for a y minus 5. Make sure that your 5 makes it inside the square root or the 7th root, because that's important for your order. So what do I do first? Do I add the 5 across or take care of the 7th root? 7th root has to go first. You can't get rid of stuff from inside. So I'm going to have to 7th and 7. 7th power, 7th root cross out because they're the same type. So now I just have a y minus 5. And then how do I get rid of the minus 5? You're going to just plus it across. Very good. So plus 5, plus 5. So you have x to the 7 plus 5. Any questions on that? Okay, so go ahead and pull out your delta map. We're going to do one example together just to make sure you know how to kind of work through it. And then you're going to have some time to work in class. Yeah, you can plug it into my cart. Okay, you should see, do y'all see your homework for inverses? Homework 9? Okay, and then this is your first question. It should look like that. Okay, here's what I want you to do. Think about 5 pretty points from your graph. Okay, now it is easier maybe if you write them down, but I'm going to leave that up to you. If you don't think you need to write them down, then fine. Okay, but if I were to try to write these down, what would, oh, I'm on Zoom. I can do it on here. Okay, what is a pretty point on my graph? Let's start with the vertex. So what is this point right here? X first, Y second. That would be 1, -3. So then if I were to write that backwards, that would turn into what? -3, 1. So I'm going to go ahead and grid that spot. So if this were backwards, it would be -3, 1. So you're going to click right here. Okay. Next point. Let's do the intercept here and here. What is this ordered pair for the y-intercept, the top one? Right here. 0, -2. What would that be backwards? I'm going to go to -2, 0. Drop a point in that spot. Okay, now let's do the other y-intercept because I see I have 2 of them. What's this one down here? 0, -4. What would that be backwards? -4, 0 right here. How many points did I tell you you're going to have to do for your practice? 5. So we have 3. We need 2 more pretty points. Okay, I noticed that I also have x-intercepts that are pretty. I have one right here. What is that as an ordered pair? -8, 0. What would that be backwards? 0, -8 would be way down here. And then I need 1 more point. Okay, you can pick any point, but I'm going to pick this one because I kind of like when they're like symmetrical. Okay, so that'd be left 8, and then it looks like down 6. So that'd be -8, -6. But then remember, I have to reverse that when I regraph it. So it would end up being what? -6 and then -8 for the y. Okay, and as soon as you graph that 5th point, do you see how the whole thing should fill in for you? Now, if your graph looks messed up, or if it doesn't hit all your points, that means one of your points is off. Okay? Also, what should you be able to see when you look at that diagonal? Symmetry, very good. So if I were to look at this, do you see how when this line comes through here, okay, I could kind of draw somewhat that I have almost like kind of like a little heart, and then the line cuts right through it. So if that doesn't happen, you know that you kind of messed up somewhere. Okay. Then as you go into your inverses, you can do the 2 linear. There are 2 cubic and 2 cubic root. If you will, please, once you're finished with this question, go into the cubic question. There are 2 of them, just go into the top one. Okay. Am I good to pull this question off the screen? Okay. All right, so go into your cubic question. How do I get rid of a cubed? We talked about it in your notes. You're going to have to use what? A cubic root, right? So let me show you where to find that so that when you do that question, you know how to type it in. Click on your keyboard right here. Okay, you'll notice that right away you have a square root. Okay, but that's not actually what you want. So you're going to need to hit shift right here. And then you'll notice that a cubic root option will pop up. Okay, so when I hit shift here, I see that my cubic root is going to be in this spot right here. Cubic root right there. Make sense? Okay, so you're going all the way till the quadratic examples. Stop there because we'll have to finish the notes. Go to that last page of your notes. Okay, there's something a little weird about quadratics and square roots. So that's why we're doing these two families separately. And oops, I was on the wrong page. We're gonna start with the squared side right here. Okay, so for starts, let's just sketch where that graph would be. So we have a +6 and a +3. So which way are we shifting? Left and up. Very good. So go left 6 and up 3. So left 6, up 3. And then we know because of the squared that it's going to be a parabola. So you're going to go over up 1, over up 3, and then over up 1 and over up 3. It should look like that. Okay, now let's find the inverse. Now I could have you write down the little pretty points and then flip them. Okay, that works for graphing, but we're going to do this one algebraically. So if you'll take the x and the y and flip them, also remember what I said, that if it's f of x, that's really the same as y equals. Okay, so when I'm switching the letters, I'm going to switch that to an equals x just like before. So x plus 6 is now y plus 6 plus 3 equals x. All right, what are we going to do first? Pretend it's the same as the ones you did on your practice. Okay, get rid of the 3 by minusing. So now I have y plus 6 squared x minus 3. Next step. How do I get rid of a square? Okay, now, what is the rule with square roots that you don't have to do with cube roots? Do any of y'all remember? Okay, does this look familiar? Plus or minus? Okay, you only have to do that with even roots. So for cubic roots, you don't have to worry about this rule, but for square roots, you do. So my square and my square roots still cross out. How do I get rid of the y plus 6? I'm going to have to subtract it across. And then just like before, I'm going to have to subtract it in the back. So it'd be x minus 3 inside plus 6 on the outside. Okay, but here's the problem. Technically, that's not one equation. That's two different equations, right? I have the plus square root of x minus 3 plus 6, and I have a minus square root of x plus minus 3 plus 6. So technically, yes, it should be minus, actually. That should be a minus. I just wrote it down wrong. Okay, so technically, that's two different equations. So let's do the positive square root first. So if I graph y equals x minus 3 minus 6, where would I shift it for the minus 3? On the graph, right? To the right 3 and then down 6, right? So it'd be right here. And then if I'm doing the positive square root, then I would go up over 1, up over 3, connect my dots. There's my square root. Okay, but remember that plus root 6 was not the, or root x was not the only answer. There was also a minus root x minus 3 minus 6. And how would these graphs look different? What does the negative in the front do that wouldn't have happened up here? Takes the graph and does what? It like flips it, right? So my other half of this would still start here, but it'd be down over 1, down over 3. So you actually end up with two different answers. You have the positive square root on top and the negative square root on bottom. So let's come down here and fill in some of these blanks. So I'm going to put here Okay, that's actually two separate functions, a plus and a minus on the square root. So to address this issue, okay, what we do with quadratics that we don't have to do with other equations is that we're gonna take the quadratic, the parabola, and we're always gonna cut it in half so that we know whether we want the plus square root or the minus square root. So draw in your diagonal for me. Okay, draw in your diagonal for me. Okay, and then turn it sideways. Okay, do you see that this side and this side go together? And then do you see that these sides go together out here? Okay, so I'm gonna color code mine. If you want to borrow a highlighter later, you're welcome to. Okay, but this is the way that they match up. The inside two are matches, the outside two are matches. So now let's fill in your blanks to figure out which one's which. So if you are doing the right side of the parabola, that is going to correspond with the positive square root. So fill in the blank down here. If you're using the right side of the parabola, that's going to be the positive square root branch. If it's the left side of the parabola, then you're going to use the negative square root as your inverse. And the way that you pick a side is that you're going to pick either from the vertex to the right or the vertex to the left. How would I do vertex to the right? A greater than or a less than? Okay, greater than. And what x does my split happen at? So then I would say for x is greater than -6 to show the right side. And x is less than -6 would be the left side. So when you get to those quadratic examples on your practice, it's going to be picking a side, and that will tell you whether to pick the plus or the minus on your square root. Okay, so let's go down to number 7. We'll do probably 2 more, and then we'll do an example off your practice. Okay, go down to number 7. We're going to skip the graphing on it only because the graphing kind of makes it take longer, and we don't have that much time left. So switch your x and your y. So it's going to be 2y minus 2 squared minus 1 equals x. What do I do with the minus 1? Okay, add it to both sides. Very good. So I have 2y minus 2 squared x plus 1. How do I get rid of that 2 in the front? That's a multiply by 2, so I need to divide by 2. So I'm going to apply a 1/2. Okay, all of this so far should look the same. Okay, then I get to this step right here, y minus 2 squared, 1/2 x plus 1. How do I get rid of the squared? I have to take the square root, right? And when I take the square root, I'm going to pick a plus or a minus, not both. So look back at your original equation. I wanted x's less than 2. Is that the left side or the right side? Okay, and now look right here. The left side will correspond with the negative square root. So instead of putting a plus and a minus, I'm only going to put a minus because I'm choosing the minus based on the side that I started with. Okay, then from there, I need to get rid of my minus 2 right here. So I'll do negative square root 1/2 x plus 1 and then add the 2 in the back to cross it out. Does that make sense? So if it starts off as a right side, you're choosing the positive. If it starts out as a left side, you're choosing the negative. Okay. Go ahead and turn the page. We're going to do one more going backwards, and then we'll do a practice question together. So if you start with the squared, you're doing a square root. If you start with the square root, we're going to undo it using a squared. Last example. Okay, the positive square root is gonna correspond to the right side of the equation. You're gonna use an x greater than to restrict domain. A negative square root corresponds to the left side, which means you would use a less than to restrict the domain. So let's just do this top one. Take your equation, switch your x and your y. Subtract the 3 across. So you have y minus 1, x minus 3. How do I get rid of the square root? Square both sides. And then right here, when I square both sides, I'm going to keep track of which side I want. Was this a positive or a negative square root? Was it originally a positive or a negative? That means that eventually I'm going to want the right side only. Versus what if it had been a negative in front, then I would want the left side. Okay, so then let's keep going. I have y minus 1, x minus 3 squared. How do I get rid of the minus 1? Plus it to the back. So I want x minus 3 squared plus 1. Okay, however, I don't want the whole thing. My vertex, if it's an x minus 3, means that my split is going to happen at positive 3. But do I want x is greater than 3 or less than 3 if I want the right side only? Okay, if I want the right side, I want only x is greater than 3. Okay, and those questions on your practice are multiple choice. So I was thinking we could just maybe do the last one together to make sure that you got it. Okay. So I'll go ahead and pull that question up here. Okay, last question. I'm just gonna do it in the space on that same page. Okay, but it says this. Okay. All right, so write the equation down. Go ahead and switch your x and your y. So it's gonna be negative square root y plus 10 and then plus 1. All right, what are we doing first? The plus 1 has to go to a. So I have y plus 10, x minus 1. What do I do next to get rid of the square root? Square both sides. And when I square both sides, I'm going to pick left or right. If there was a negative on my square root, which side am I choosing? That's going to be a left side. When I get there, I'm not there yet, but I'm thinking to myself, because originally there was negative here, I'm picking the left side. These cross out. X minus 1 squared. And then how do I get rid of the plus 10? Minus 10 across to the other side. So I have y equals x minus 1 squared minus 10. But then where is my split going to happen if my parentheses is an x minus 1? The split's going to happen at 1, but I have to pick less than or greater than. Which one do I want? Less than, because it was originally a negative, which means the left side. So it would be for x is less than 1. And then if you look at your answer choices, I think that's the top. Okay. All right. So you still have a little bit more than 10 minutes. Please ask me if you need help. Knock out those last 3 questions. And good job. Sorry, it didn't end up being that much time, but okay. Okay, to your cubic root. Move into that. That's a slow root. Backspace that, hit shift, and then use the But you actually did it correctly.
Where's your work right here? For two.
Oh,
So just take your divide by 12 on the bottom, negative divide by 2. And now, do you see how your fraction and that fraction are the same? You want the whole x plus 12 on top. So erase your x and then put it on the top. You see what I mean? Like x plus on top. And then don't forget to change that bottom number to 2. Oh, plus 2. I know. So you. We have 12. It's okay. First of all, period, so could you just start first? Okay, and then I'm gonna email you, you to come in, you teach a professor, but I just need you to write the practice needs, because you line straight from the line step to against. Okay? Yes, sir. Oh, why do we do that? Okay, so right here. Times by 2, right? So it'd be a 2x. Or you could do this. With the 2 in the front and the root like that. But you can't keep this at 10, you either have to do 2x plus 20 or keep it in parentheses like that. Does that make sense? But then other than that, it looks correct. Yes, ma'am. In the front of the square root, yes, ma'am. So do you do okay? You finished? Yes, sir.
feels like right.
So you do +1, you need to put parentheses around that, because you have to 1/6 the whole thing,
Around,
the x plus the 9.
Okay.
Because you had already added the 1 and then divided both of them by 6.
okay.
Then you cubic rooted, and then +7 should go to a -7.
Thank you.
Yes, sir.
Did it come from? Oh, okay, yeah, sorry. Probably about 6 minutes. Sure. Yes. That's okay. Is it a left side or the right side? Or next left. Left and left. Because remember how it's plus or minus.